Okay. We started yesterday talking about right triangle, trig, what does a standard position angle look like, positive rotations, move in the counterclockwise direction, and clockwise move in would be the negative rotation. Okay, we referred to the reference angle or reference triangle that was listed there for a 120 degree standard position angle. We drew that one in class. Obviously 0 being over here on the right, and then measuring past the 90 degree mark at the top, past it 30 degrees to get to 120. And that created that cool 30, 60, 90 right triangle. And then we looked at 225. And that was down in quadrant. Oh, by the way, do you know your quadrants? Right. It's because of the way that you spell quadrant. Do you know how to spell quadrant? C-W-A-D-R-A-N-T. Quadrant. Right? 1, 2, 3, 4. Okay. It looks like a capital C, 1, 2, 3, 4. No, you don't spell quadrant that way. It's just a way. I'm just trying to help you remember. Okay? So 225 is down in quadrant 3. And we looked at the coterminal angle, the purple one, negative 135. And then we looked at another coterminal angle going around the circle more than once. 585 is another coterminal spot. Those are things that we reviewed yesterday. We got into this barely, reminding you about SOHCAHTOA from geometry class. That sine was opposite over hypotenuse, and cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. There are 3 new trig functions in town. Okay? They are reciprocal trig functions. Can you remind me what a reciprocal is? You flip the fraction, right? Fraction. Okay? So if I say 2/3, reciprocal is 3/2. That's what you say at the dentist's office. Okay? So you got 3 halves. Did you? Okay. So what about 1/5? 5. Nicely done. How about 0.723? 1/0.723. Remember the idea of flipping it over? Anything can be divided by what? So when I say 0.723, that's 0.723 over 1. That's why when we flip it, we get the other thing. That would be how you could tell your calculator to come up with the actual weird decimal. Now, can you tell me how you could tell your calculator to do the same thing with 0.723? Another way to do the reciprocal that we taught you in Algebra 1 and Algebra 2. How can you find the reciprocal of something besides taking 1 over that thing? You take something from the numerator and change it to the denominator. Negative what? Give me more information. Negative what? Something about a negative, yeah. Can you recall raising something to the negative first power? Right. So if you take any value and you raise it to the negative first power, it flips it over. That's another way you can tell your calculator to do that. Awesome. Okay, so these are reciprocal trig functions. Reciprocal trig functions, I guess. It's these over here. Sine has its own reciprocal, and it's pronounced cosecant. But when you want to abbreviate it, you write CSC, cosecant. Cosine has its own reciprocal. It's pronounced secant, but it is abbreviated SEC for Southeastern Conference. Never mind. Tangent has its own. It's called cotangent, and it's abbreviated COT. How are we going to remember which one goes with which? So I'll tell you what I did when I was your age. I noticed that these started with the opposite letter. If the original trig function started with a C, I knew that the reciprocal one started with an S. If you are having difficulty telling which one goes with tangent, if you're telling me that cotangent, you don't know which one it goes with, we're in some serious trouble. That should be the easy one, right? But I understand these other ones are new. So just remember they start with the opposite letter. Alright, if sine goes with cosecant, and it's a reciprocal, and if sine was opposite over hypotenuse, what would cosecant be? Hypotenuse over opposite. If cosine goes with secant, and it's reciprocal, what do you do with adjacent hypotenuse? Hypotenuse over adjacent. And if tangent goes with cotangent, and it's a reciprocal trig function, what do we do with opposite and adjacent? Introducing Choshikan, the Japanese counterpart to the original Sokoto. Whatever can help you remember. Choshikan. It really isn't that bad. Once we start doing these reciprocals, I mean, you're just going to be flipping them over. You won't have that much difficulty. So, let us go back to our geometry days. Yes, you can eat that. Okay, so, if we got a 45-degree angle, what kind of cool triangle is this? 45, 45, 90. Do we remember from our geometry days the relationship between the sides and the hypotenuse? Several people have told me no today. You would not be alone if you tell me that. You do know it's isosceles, right? That means those two sides have to be the same, whatever they are. So how do we find the hypotenuse? You could do the Pythagorean Theorem, right? If you want to call this side C, we can do that. So we'd have x squared plus x squared equals c squared. And what is x squared plus x squared? 2x squareds, right? If we count them up. Okay. Yeah, you did the multiplication thing. All right. Now what? How do we get c by itself? What do we do? Square root. Alright, so what is c equal to? Now it has come to my attention that we possibly don't remember how to simplify radicals. This is a very going on with this thing? It comes outside the radical, but your friend or family member, too, is not coming out. All right, so hopefully this rings a bell that you take the side length and multiply by radical 2. All right. Let's make our lives a little bit easier. And we'll call each one of those sides 1. What would that make the hypotenuse? Radical 2. Good call. So, what's the cosine of 45 degrees? Think back to your adjacent over hypotenuse. Look at the triangle. Tell me what it is. Something over something. Yeah, what's my adjacent side? I did hear somebody today tell me this. I have difficulty figuring out which one is opposite, adjacent, hypotenuse. So I'll tell you what I did when I was learning this a long time ago. Find the opposite side first. We always know which side is the hypotenuse because it's across from the 90-degree angle. That only leaves us with one left. Okay, so what's my fraction going to be? 1 over radical 2. Okay. That is technically the right answer, folks. You will see, crazy mathematicians who rationalize it because most of the time nobody's going to write 1 over radical 2. It is technically correct. Most of the time they're going to write radical 2 over 2. Okay, for that cosine. You won't see 1 over radical 2 most of the time. Yes.
Well, how did you get that? Wait, I'm confused. How did you get that?
They asked me. Okay, good question. They asked me for all 6 trigonometric functions. So I just started with cosine. It doesn't matter which one you start with. I have to find all 6 of these.
Oh,
okay. So, good question. Sorry. I skipped over that really quick. Okay, how about the sine of 45? Sine of 45. Yeah, what do you got? That's true. I like that. What numbers? 1 over radical 2. Oh, it's the same thing. Wow. How about the tangent of 45? Say it. Yeah, opposite over adjacent is a plain old 1. Alright, now secant of 45. Secant goes with which trig function? It goes with the cosine. So here's my question to you. Which one of the purple boxes I'm drawing right now would be the easiest to find the reciprocal of? First one or the second one? First one or the second one? It is the first one. They're both the same values. Why can't I use the first one? And what would you tell me? What's the reciprocal of 1 over radical 2? Radical 2. Right, you flip it over. That's it. How about cosecant 45? Which one does cosecant go with? Right, starts with the opposite letter, so it has to go with sine. What do you got for me there? Radical 2, thank you. and I'm going to close my eyes and see if you guys can come up with the next one. Maybe. What do you got? 1. Thank you very much. Yeah, that's the hard one, right? Flip that thing over. Okay, but that's it. Those reciprocal trig functions are not that complicated. You just have to remember which one goes with which and just find the reciprocal of it. Okay? Another trip down memory lane. What is the relationship on the good old 30, 60, 90? Remember, everything hinges on the short leg. What? No, it's not the special three. It's not a Pythagorean identity or Pythagorean triple 3, 4, 5. It's the 30, 60, 90. Do you remember what to do to the short leg to get the hypotenuse? Maybe? Okay, good thing this is written at the beginning of every SAT. Alright, so you double it. Remember that? So if I do that, you remember the other one? The long leg? You multiply by what? Radical 3. Thank you very much. Okay, so that was the pattern we followed for that one. Yes?
Are we gonna have to know all that?
Yes. Yeah, that's kind of a basic thing you need to know. Yep. Okay. So let's make our lives easy here and make this a 1. What does that mean about my hypotenuse? What does that mean about my hypotenuse? 2. Nice job. What about the long leg at the bottom there? Radical 3, thank you. Alright, so cosine, sine, tangent. Cotangent. Secant. Cosecant. Find all 6 of them now. Okay, cosine 30. What do we get for cosine 30? The adjacent side over the hypotenuse. Which reciprocal trig function goes with that one? Secant. Yeah, if you are at a party, you don't want to say sec. You want to say secant. Okay. I'm just trying to help, man. I know what you're throwing out. Okay, so I didn't write it straight across from the other one on purpose. Yes, that's true. Some of you are rebels, and you wrote them straight across from. It's okay. I understand. You're trying to keep them straight in your mind. I was just trying to see if you could adjust. So what did you do with secant? If we got radical 3 over 2 here, 2 over radical 3. Of course, we would want to rationalize that. Not that that's the most important thing on the planet, but 2 radical 3 over 3 is what you'll see most often, even though 2 over radical 3 is exactly the same thing. Sine of 30. Opposite over hypotenuse was 1/2, and it goes with which trig, reciprocal trig function? Cosecant. Cosecant. So that gives me a cosecant of 2. Right? You just flip it over. How about my tangent? Opposite over adjacent. Now, I think I know what you're getting at. You did this, didn't you? Yeah, so you were ahead of me. I'll catch up to you. You're right. Radical 3 over 3. Good. Tangent goes with cotangent, obviously. So what is the cotangent of 30? Remember I said choose the one that's easiest to flip over, which would be that one right there. Yep, go. Yep. Yeah, I'm gonna talk to the other math teachers. I like the idea of accepting this. Mr. Rupert's asking if I can accept 2 over radical 3 as the correct answer. I actually like that idea. Rationalizing is kind of an older concept. You're just not going to see that. Like if you're looking in the book, you might, or you're just not going to see that very often. But as far as a test answer, yeah, I'd probably get it. Let's see what the other teachers think, but especially the calc teachers, because they're the ones that really need to kind of dictate that. Okay, so using one trigonometric ratio to find them all. Sounds like Lord of the Rings. So we've got some triangle, a right triangle. They have told you one of those sides is equal to 5. We'll put theta down here in this corner. They have told you one of those sides is 5 and one of those sides is 6. Which one goes where? Pay attention to the fact that they told you that the sine of theta is equal to 5 over 6. Which side is 5 and which side is 6? Where's the 5 go? Opposites. Where does the 6 go? Hypotenuse. Find the remaining side quickly, please. Find the remaining side. How should we do that? Knowing 2 sides of a right triangle, how do we find the remaining side? Is that a green line? 0? Yes. I just put green. Okay. Does it confuse you if I do this? Does that confuse you? If it does, then don't think about it like that. Think about it like you would back a while ago. X squared plus 5 squared equals 6 squared. And then x squared plus 25 equals 36, which means x squared has to be 11. You can still get to radical 11. I know. I'm trying to speed that whole process up in your mind. If you know the two legs, you would be adding and taking the square root. If you know the hypotenuse in one leg, you would be subtracting and taking the square root. But if that doesn't make sense, then go with what you're comfortable with. Okay. We already know that one, right? So find the rest. Alright, what do we get for cosine? Cosine. Adjacent over hypotenuse. Radical 11 over 6. How about the old tangent? 5 over radical 11. Also known in certain countries as 5 radical 11 over 11. Sorry, I'm squeezing it in there. How about the cosecant? 6 over 5. That was nice. How about the secant? 6 over radical 11. The math teacher is forced to rationalize just because it's been programmed into him. Yes. Okay, and how about the good old cotangent? Radical 11 over 5. Okay, grab your calculator. Grab your calculator. First, turn it on. You gotta tell them, otherwise they won't know. Okay. Next, I want you to go to the Edna button. I'm pointing right at the Edna button right now. Edna mode? Come on, my Incredibles fans out there, seriously. Okay, yes, Edna mode. Okay, which was played by a guy. That was interesting. I was shocked. I was like, did a good job. All right, now, at the mode button, we did want to move down to that one right there. Make sure yours is on degree. If you're not in degree mode, we're in trouble for these questions. Sometimes in this chapter and the next, we will need to be in radian mode. Sometimes we'll need to be in degree mode. For all the triangle stuff, we're going to be in degree mode. I'm not going to ask you for a radian measure of some weird decimal, okay, inside of a triangle. So we will need to be able to go back and forth between those two. But we're going to need to do this in degree mode. Oh, when is it going to matter if I need to have my calculator in radian or degree? Hey, if you're doing the Pythagorean Theorem, has it ever bothered you? That mode right there, has it ever bothered you when you did the Pythagorean Theorem on a calculator? Did it ever bother you when you added 5 plus 7? No. The only time it's ever going to make a difference is if you're doing sine, cosine, or tangent. Oh, and by the way, those of you who are going to answer these secant, cosecant, and cotangent button on the calculator, the answer is no. So if you want a decimal for some weird secant, cosecant, or cotangent, what are you going to have to do? What? What are you going to have to do? If you know the sine, cosine, and tangent, then you have to find the secant, cosecant, and cotangent, and your calculator doesn't have one of those buttons. Find the inverse, thanks. Just flip it over, right? 1 over that, or raise to the negative first power. Okay. Now that you've done that, go back to the home screen by using the quick feature, which you'll all do in about 6 minutes. Now, I want the cosine of 30 degrees. Cosine of 30 degrees. And is 0.866. Wow, that's a bad spot. Let's see if I can do this a little change. Yeah, it's a little bit better. When I was in high school, when I saw 0.866 show up on a calculator, I knew that was radical 3 over 2. You know that's radical 3 over 2 because you wrote down radical 3 over 2 in example 1. When we asked you for the cosine, it might have been example 2. When we asked for the cosine of 30, you wrote radical 3 over 2 in the triangle. It's 0.866 in terms of decimal. How about the sine of 30? What's the sine of 30? 0.5. Well, we knew that because you wrote down the fraction 1/2. What about the cosine of 45? That's another popular one. No. I changed the angle. Cosine 45. 0.707. Every time I saw 0.707, I knew exactly what fraction that was. Look at your example 3, I believe. Example 3, I bet you know what 0.707 equals. What's the fraction? 0.707, look at example 3. Cosine 45. Cosine 45. Cosine 45. You got any fractions for me? 1 over radical 2 is a version of it, or radical 2 over 2. Okay, that's the 0.707 nasty weird decimal version. But you'll see that show up quite a few times. Solving a right triangle. A right triangle with a hypotenuse of 8 includes a 37-degree angle. Do you think it matters which one I picked for 37? No. it A, B, and C. Find the other two angles. Now, correct me if I'm wrong, but didn't they just tell me it was a right triangle? So don't I know one of them pretty quickly? So angle C, we got that one, right? Hopefully that one's an easy one. We know angle A, they gave that to us. What about angle B? Yes, say it louder. 53, you're right. How'd you know that? From? Okay, so you added them all up to 180. That's true, you could do that. You could also realize that these two angles right here are extremely nice to each other. We call them complements because they add up to 90. Okay, so we found the two angles. And now it says find the lengths. We'll call this one y and this one x. How do we find x? I mean, not that you would really want to find your x because you probably wanted to part ways with them a long time ago. But let's find x. Which trig function are you going to use? We're trying to figure out the adjacent side. We have the hypotenuse. Which trig function is that? Yeah, say it. That is cosine, right? So the cosine of 37, we got this one, and we'll solve for y here and we'll be done. Stay with me. Don't go to the light. Adjacent over hypotenuse. How do you solve a proportion? How do you solve any proportion in the universe? You cross multiply. Now I know some of you are going to say to me right now, why don't I just multiply by 8? I do understand your point. Listen. These problems are not always going to look exactly like this. Sometimes the fractions are going to be flipped. You need to understand it's a proportion and that in order to figure out these values, you're going to have to cross multiply to get your answers, which I shall do right now because I care, even though you guys are checked out. 6.4 for this one. Make sure you're not ignoring homework this weekend. I know some of you want to. Don't do it. Make sure you're giving some effort on the odds.